So we're going to find the equation of a quartic function. Quartic means it has a power of 4 with 3 zeros, one at 2, one at 4, and one at -1. And notice the -1 has a multiplicity of 2. And it has a y-intercept of -4. So let's make a quick sketch of this, a rough sketch of what this could look like. We have a root at 2, a root at 4, and a root at -1. And because it has a multiplicity of 2, it means it's just going to come and kiss the graph at this line, this point right here, which means it's going to either look like this or like this. Just touch it at that point. We don't quite know which direction at this point. We also know that there is a y-intercept of -4. So here are my 4 points that I know on the graph, and in order to make a graph that looks like it would fit, I'd have to graph it like that. Now, oops, I didn't quite go through the 4 here. So that would be an example of a polynomial that meets all the conditions that were given in the question. So now let's find the equation of such a graph. I am going to write out the roots. So the roots are x minus 2. The root is 2, which means the factor is x minus 2. A root of 4 means the factor is x minus 4. And a root of -1 means the factor is x plus 1. And a multiplicity of 2 means it's going to be squared. And that is a polynomial with the given roots. What we still need to find is this stretch factor or vertical expansion factor, and we use the last bit of information, which is the y-intercept or the point 0, -4 to do that. So since 0, -4 is on the graph, it has to work in the equation, and if it works in the equation, I can substitute it in. So I'm going to substitute in 0, -4. So the y value is -4. A we don't know. 0 minus 2, x is 0, 0 minus 4, and 0 plus 1 squared. So simplifying the right side, I get -2 times -4 is positive 8, so I get 8a, and that allows me to isolate a. So a is -1/2, dividing both sides by 8. So my final equation is y equals -1/2 x minus 2, x minus 4, and x plus 1 squared.